So, ladies and gentlemen, let's continue working on these last two application problems here. So we're talking about movie ticket sales decreasing each weekend after opening. Okay, the function 49.9 times 0.692W models the earnings of a popular movie. In this equation, E represents earnings in millions of dollars, and W equals 0, it represents opening weekend. So we want to graph the function and then estimate how much money they made opening weekend. Well, opening weekend is going to be when W equals 0. So really that's just asking our y-intercept. So let's go ahead and make our chart. So we have 0, and you guys might need to actually draw a chart on your note sheet there. So 0, 1, 2, 3, and 4. So what we're going to do is we have 49.9 times 0.692, and we're going to be raising that to the 0 power, to the 1 power, to the 2 power. So you're going to be doing that for all of those. And then for this one, you end up getting 49.9. And I'm just going to round it to the tenths or to the hundredths place, okay? Then when you raise to the first power, you end up getting 34.5. And so it's going down, okay? Because if you think about it, movies are most popular when they first come out, and then they decrease in popularity after that. And then we have 23.89, and then 16.54, and then 11.44 as you work your way downwards. So we need to go ahead and we need to change our scales. So I think what I'm going to do is I'm going to go up by 5s. So this is 5, and I'm just going to count from there. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So 49.9 is going to be about right there. 34.5, well this is 50, 45, 40, 35, so this is going to be just below 35. And then for 23, here's 30, and then 25, and then 23 is going to be about here. Then we're going to go to 16, so here's 20, and then 16 is going to be just above 15, and then 11 is going to be just above 10. So now we can go ahead and we can graph that function going down. Again, it's not going to be exact. And so there's our graph to estimate the function. Then estimate how much money the movie made during opening weekend. Well, there's how much money it made in opening weekend. It made 49.9, and remember that our label on this is in millions of dollars. So I'm going to put that million at the end. So basically it was $49,900,000 on that first opening weekend. All right, let's take a look at this next one. So some people say the value of a new car decreases as soon as it's driven off lot, and that's actually true. The more you drive your car, the less money it's going to be worth. Okay, so the depreciation value of a new car originally cost $25,000. So it gives us that equation to model. So now we're going to go ahead and plug in our x and y values. Excuse me. So we have 0, 1, 2, 3, and 4. So what I'm going to do is I'm going to take this equation. I have 25,000 times 0.82, and now I'm going to raise it to the 0 power. That's what it's going to be when I first drive it, which would make sense that that would be 25,000. Then I'm going to take that 0.82 and I'm going to raise it to the first power. So 25,000 times 0.82, well now it's only going to be 20,500. So after only a year, we've almost lost $500 worth of value in our car. And then for 2, after 2 years, when you plug in 2 for that exponent, you get 16,810. Again, be plugging this in with me. Make sure you're doing it correctly. Then you're going to get 3, which is 13,784. Okay, we're at half the value. Okay, it's almost half the value of when we originally bought it after 3 years. And then for 4, you get 11,303. So what I'm going to do is I am going to go up by... Let's go up by 3,000. So we have 3, 6, 9, 12, 15, 18, 21, 24. So 25,000 is going to be about right there. It's always a good idea to kind of give me an idea of what your scale is on your homework and on your quizzes as well. So then 20,000 is going to be just below 21,000, which is right there. 16,000 is going to be just above 15,000, which is right there. 13,000 is going to be about there, and 11,000 is going to be a little bit lower, probably about there. So this is us going down, representing our depreciation value right there. Okay? So then, next, we want to figure out what the value of the car is going to be in after 5 years. So what we're going to do is we're going to calculate it out as if we were doing a fifth value. So we're going to take 25,000 times 0.89 or 0.82, I'm sorry, and raise it to the fifth power. Go ahead and punch that in your calculator. When you do that, you end up getting 9,268.496. So in money, we only want to use 2 decimal points. That third decimal point is 5 or greater, so I need to round 9 up. Well, when I round 9 up, it becomes 10, so I end up needing to round the 4 up to 5. So I get 9,268.50 and then dollars for that one, okay? Let's take a look, last but not least, at 9 and 10. So for number 9, does it show exponential behavior? So to figure out if it shows exponential behavior, what I do is I divide backwards. So I do 25 divided by 10, and that gives me 2.5. Because to be exponential, you need to be multiplying by the same number. 62.5 divided by 25. Well, so far so good, but I don't want to assume it's just going to work out. 156.25 divided by 62.5. So they're all 2.5. So yes, it does. So let's go ahead and graph that exponential behavior. So I went up by tens, and this side also went up by tens. So what we're going to do is we're going over 10 up 0. That's going to be here. And then we went, or sorry, over 0 up 10 is going to be here. Over 10 up 25 is going to be here. Over 20 up 62.5, there's 30, 40, 50, 62 is going to be just above it. And I'm not going to get to 156.25 at all on this graph, so I don't want to cross over to 3. Again, it's a good idea to tell me and label your scale on each of your graphs. Next, let's go ahead and let's take a look at number 10. So we want to figure out if it's exponential. So I'm going to, again, divide this way and make sure I'm dividing by the same number. So 0.5 divided by 1 is 0.5. 0.25 divided by 0.5 is 0.5. 0.125 divided by 0.5 is 0.5. So yes, they're all being multiplied by the same thing, and that's 0.5. So what I'm going to do is I'm going to go up, and I'm going to call this guy 1 right here. So really, each of these marks 0.25 of a square, and I'm going to have this one be representative of 1. So we're going over 0 up 1, that's going to be that point there. Then we're going over 1 up 0.5, and that's going to be there. Over 2 up 0.25 is going to be there since we're going up by 2.5, and 1.25 is going to be there. Remember, again, when you're drawing these exponential functions, we don't want to be crossing that y or the x-axis, so it's just going to kind of sit on it. So that concludes your note video, and you can go ahead and finish up your practice sheet. Thanks for listening.